So in our previous units, we learned how to solve a quadratic, and remember a quadratic is an equation that has an x squared term in it. We learned how to solve a quadratic using different factoring methods. So our different factoring methods included the diamond method, bottoms up. Oh, our very first method ever was GCF. So we had GCF, diamond method, bottoms up. We had difference of two squares. And then we also at the very end learned what a perfect square trinomial was. So we had 5 different methods. But each of these is considered factoring. Okay, which means that all of those equations were factorable. So how do I solve an equation that's not factorable? We're going to learn two methods, and the first one of those is called completing the square. So to complete the square, we're going to be actually working with perfect square trinomials. So just to remind ourselves what a perfect square trinomial is, it is a trinomial in the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So notice that the b squared term is always a positive, but the middle term can be either positive or negative. And a and b are both going to be either variables or numbers. So an example of a perfect square trinomial is x squared plus 8x plus 16, because notice that the first term is a perfect square, and the last term is a perfect square. And remember, we could factor this using one set of parentheses with a squared on top. The square root of x squared was x. The square root of 16 is 4. And we always take the middle sign. So we could factor this in just one step using a shortcut as x plus 4, all of that squared. Now, one thing we need to notice is that if you notice, our middle term here is 8. Now, if I take 8 and divide it by 2, that gives me 4. And then when I square 4, it gives me 16. And this will always be true for a perfect square trinomial. I can take that middle term, divide it by 2, and then square it to get this term right here. So, we're going to practice that, but first we want to take our steps to completing the square. And I know this is a lot of steps. You will use them every single time. Most of them are already written out for you. So all we have to do is fill in the blanks and follow these 7 steps every time. So to complete the square, we want to move any constants, which means there's no x involved. So in the example I just gave you, the constant would be 16 here because there's no x's attached to it at all. So we want to take any of the constants, no x's at all, and move it to the right-hand side of the equation. So that's our first step. After we've done that and we only have x's, we are going to add blank spaces on both sides of the equation, and I accidentally typed that out for you. So you're going to add blank spaces on both sides of the equation, because whatever we're going to be adding a number in those blanks, and whatever we do to one side, we have to do to the other. So how do I know what to fill in those blanks with? Well, I'm going to fill in the blanks with the term b divided by 2 squared. So I'm going to take that middle term, the term that's a number times x, I'm going to divide it by 2, and then I'm going to raise it to the second power, and that's going to give me the blank for each side, which will make my left-hand side a perfect square trinomial. So step 4, we're going to have a perfect square trinomial, so we are going to factor the left side of the equation. And I'm going to write myself a note right here. It will be a perfect square tri. Okay? So if it does not come out to be a perfect square trinomial, that means you did something incorrect. So it should always come out to be a perfect squared trinomial. So when we're a perfect squared trinomial, we'll be able to solve for x by taking the square root of both sides. And remember, what we learned yesterday is that every time you are the one drawing in the square root, the right-hand side must be equal to plus or minus whatever it is you get. So step 6, after I take the square root, I'm going to have two equations. So I'm going to want to write the answer as two equations. And then I will be able to solve for x. And that is how we complete the square. Now let's first start with example 1. All I want us to do is find the value that makes each expression a perfect square trinomial. So we're just actually looking for that n term. This is going to be the blank when we're completing the square. So always I take that middle term. So n is going to be equal to the middle term, -2, divided by 2. Always divide by 2, and then square it. So that n term is going to be -2 divided by +2 gives me -1. And -1 squared gives me +1. So that n, we want to be a +1. Now let's test it. So if I were to plug n in, that would give me x squared minus 2x plus 1. And I want to factor this. So if I were to factor this, I would take the square root of x squared, which is x, the square root of 1, which is 1, and that middle term, which is negative. And then always with perfect squared trinomials, we raise it to the second power. So it works. So that's how we're going to find this blank every single time when we are completing the square. So for example 2, let's actually try completing the square. Now I did make a typo here. I don't want it to be x squared plus 9x. I want it to be x squared plus 10x. So make sure that you make that change. So our problem is x squared plus 10x equals 136. So the first thing we have to ask ourselves from step 1 are the constants all on the right-hand side? Now 136 is on the right-hand side. So I'm good there. So step 2 is to draw my blanks. So I have my x squared plus 10x plus blank equals 136 plus blank, because whatever I do to the left-hand side, I have to do to the right-hand side. So what we want to do is figure out what number is going to make this left-hand side a perfect square trinomial. So we're going to do what we just did in example 1. I want to fill in that blank. So I take the middle term, which is positive 10, divide it by 2. Sorry guys, the lights went off on me. I take the middle term 10, divide it by 2, and then I square the whole thing. So that's going to give me 10 divided by 2, which is 5 squared, which gives me 25. So I'm going to take that 25 and fill it into both of the blanks. Now this left-hand side is a perfect square trinomial. The first term is a square, and the last term is a square. So let's factor it using the special case that we already know. The square root of x squared is x. The square root of 25 is 5. And the middle sign is positive. So x plus 5 squared is equal to 136 plus 25 is 161. Okay, now I want to solve x. Now I have this x plus 5 squared term all by itself, but I want to get rid of that square. So the opposite of squaring something is taking the square root. So I take the square root of both sides. And that is going to cancel each other. So we will be left with x plus 5 equal to, now remember, every time I am the one taking the square root, my answer needs to be plus or minus. And the square root of 161. 161 does not break down at all using a perfect square. So we can't simplify this square root any more than it already is. So we just leave it as root 161. But I have not solved for x yet. I have this plus 5 here. So I'm going to subtract 5 from both sides, and that will give me an answer of x equals -5 plus or minus the square root of 161. And just like we talked about yesterday, I cannot simplify this anymore because this integer and this root are not like terms. So that is my answer, and I can leave it like that. Technically, there are two answers here because it's -5 plus square root of 161 and -5 minus square root of 161. So I actually have two answers here, but I can leave them just as this for now because we can't go any further here anyway. So what happens if I can go further? So let's look at example number 3. Example number 3 gives me x squared minus 6x equals 40. Now my constant is already on the right-hand side, so I'm good to go there. So step 2, I'm just going to add my blanks. Okay, but I need to figure out how to fill in that blank. So I take the middle term, which in this case is -6, divide it by 2, and then square it. -6 divided by +2 is -3 squared. -3 squared gives me +9. So I'm going to put +9 into both of those blanks. Now this is a perfect square trinomial, so let's factor it. The square root of x squared is x. The square root of 9 is 3. The sign in the middle is negative. And then we raise the whole thing to the second power. Equals 40 plus 9 gives me 49. Now I need to get rid of this squared term. So I take the square root of both sides, which will cancel. So I'm left on the left-hand side with x minus 3. Equal to the square root of 49 plus or minus 7. Now I'm really close to solving for x here. I want to add 3 to both sides. So that gives me x equals 3 plus or minus 7. Now I can actually go further with this because both of these are integers. So this is giving me two equations here. X equals 3 plus 7 and x equals 3 minus 7. Okay? So if x equals 3 plus 7, then x equals 10. And if x equals 3 minus 7, x equals -4. So I also have two answers here, +10 and -4. For example 4, I have x squared plus 14x equals 113. 113 is my constant, and it's already on the right-hand side, so we can go straight to drawing in my blanks. X squared plus 14x plus blank equals 113 plus blank. And I need to figure out what goes in those blanks. So I take the middle term, which is +14. So 14, I divide it by 2, and then I square it. 14 divided by 2 gives me 7, and 7 squared gives me 49. So 49 is going to go into those blanks. So this is going to be x squared plus 14x plus 49 is equal to 113 plus 49. Now the left-hand side is now a perfect square trinomial. The square root of x squared is x. The square root of 49 is 7. That middle term is a plus, and we always square it. Is equal to 113 plus 49 gives me 162. So then what I want to do is get rid of that squared by taking the square root. So on the left-hand side, that gives me x plus 7 equals plus or minus. Now the square root of 162. Let's see if I can break up 162. 162 actually breaks up to 81 times 2, and 81 is a perfect square. So this is the same as plus or minus the square root of 81 times 2. And the square root of 81 is 9. So this is x plus 7 is equal to plus or minus, we can take that out, 9 square root 2. And now I can subtract 7 from both sides. So I subtract 7, so that gives me x equals negative 7 plus or minus 9 root 2. Now I cannot combine the negative 7 and the 9 because 9 has a square root 2 attached to it. So these are not like terms. Negative 7 is an integer. 9 root 2 is a root. So we can just leave our answer as negative 7 plus or minus 9 root 2. Last example for completing the square, example 5. I have x squared minus 10x equals 40. Now 40 is a constant and it's already on the right hand side, so we don't have to worry about moving it. So I'm going to go straight into my blanks. So I get x squared minus 10x plus blank equals 40 plus blank. And now I need to figure out how to fill in those blanks. So I take my middle term, negative 10, divide it by 2, and then I square it. Negative 10 divided by 2 gives me negative 5 squared, and negative 5 squared gives me positive 25. So positive 25 is going to go into those blanks. Now this is a perfect square trinomial, so that is x, the middle term is minus, and the square root of 25 is 5, all of it squared, equals 40 plus 25 is 65. So to get rid of that squared, I'd take the square root, which will cancel, so we get x minus 5 on the left. And whenever I'm the one taking the square root, plus or minus. And 65 does not reduce at all into any perfect squares. We can't break it up. So we just leave the square root of 65 inside the root. And then I solve for x by adding 5. So my answer will be x equals 5 plus or minus square root of 65. And that's as far as we can go because we cannot simplify 65 or square root of 65 anymore. So my answer is 5 plus or minus square root of 65. So we use completing the square as a method when you cannot factor the trinomial. You need to make sure that you have all of the blanks filled in for all 7 steps and keep this. Make sure that you are referencing back to it because this gives you each step by step into solving using completing the square. So this is a very important piece of your notes that you need to make sure that you keep on hand for the homework problems.